Alright, welcome. We're going to be doing 6-5 and 6-6, so this is 6-5. Make sure that you can pause the video to be able to write these slides down. It's important that you have this in your notes. But we talked the other day about properties of a rhombus. Today we're going to talk about how we can prove a parallelogram is a rhombus in a rectangle. So we're basically doing like our converse. Okay, so one way we know that a parallelogram is a rhombus is if the diagonals, if they create a perpendicular angle. So if these two diagonals create a perpendicular angle, if it is already a parallelogram, then you know that it's a rhombus. So make sure that you guys write that one down. You can pause it, write it down. We're going to go to the next one. Again, pause it. Make sure you write this down. How do we know if it is a rhombus? Well, if you have a parallelogram and you have the diagonal and it bisects a pair of opposite angles, then it is a rhombus. So again, it's got to be a parallelogram to start with, but if it bisects a pair of opposite angles, then you know it is a rhombus. And the last one, how do we know if something is a rectangle? Well, we know a parallelogram is a rectangle if the diagonals are congruent. So if AC and BD are the same, then yes, it is a rectangle. But again, remember, a rectangle, a square, and a rhombus, they're all underneath our parallelogram family. So they're all parallelograms. They're just certain types of parallelograms. Okay? Alright, so make sure you guys have it written down. Let's keep on going. Alright, so here's our first problem. Make sure you write it down. It says, what can you conclude about the parallelogram? So you know it's a parallelogram to start with, and which one is it? Well, we see that the diagonal bisects the opposite angles. What does it have to be? That is a rhombus right there. Again, you got to know the properties of all these things. We don't have enough information after that to know if it's a square. You don't know if they're right angles or any of that other stuff that a square has. If the diagonals are congruent, any of that stuff. But you do see that the opposite angles are being bisected, so you know it has to be a rhombus. Cool. Write it down. Go to the next one. Alright, so next problem. Write it down. It says a parallelogram has a measure of 2160. So, again, and whenever I don't have a picture, let's always draw one. So I know that these are both 20, these are both 160. And I'm trying, can you conclude that it is a rhombus, a rectangle, or a square? Alright, so remember, a rectangle has all 90-degree angles. It can't be a rectangle. A square has all 90-degree angles. It's definitely not a square. Is it a rhombus? Maybe, right? A rhombus does have opposite angles that are the same, but so does a parallelogram. So it could maybe be a rhombus. Okay, how would we for sure know that it's a rhombus? Well, if the problem told me something like, well, if all the sides are the same, you would definitely know that it would for sure be a rhombus. Or if it said something like, well, the diagonals, they bisect the angle, it'd be a rhombus. Or if you had something where the diagonals make a perpendicular angle, that would be a rhombus. But because this problem doesn't say that, that's why it's a maybe. Okay, so again, you gotta know the properties. Okay, keep on going. Alright, so my third problem, make sure you write it down, and it tells me that this parallelogram, remember that symbol stands for parallelogram, is a rhombus. Alright, I gotta know the properties of rhombus. I'm like thinking, alright, we know these angles. Well, I know a rhombus that the angle is being bisected by the diagonal, which means that these two have to be the same. If they are the same, it means I need to set these two equal to each other. So I subtract 4x, I'm going to get 2x. I add 2, I get that is 10, which means what does x have to be? X has to be 5. Okay, so make sure you draw the picture down. Again, I knew I had to set them equal to each other because the angle gets bisected in rhombus. Last one for 6-5. It says, what does the value of y need to be? Okay, again, I got to know, what makes a rectangle special? Well, what makes a rectangle special is that the two diagonals are the same. Okay, those two blue lines are the same length. And remember, With a rectangle, it's still a parallelogram. So again, these two are still the same. But if those are the two lines are the same, then all four lines are the same. And again, it means that all these are the same. And if they're the same, what do I know about these two lines? They're equal to each other, so I can say 5y plus 3 is going to equal 7y minus 5. I'm going to subtract 5y, it's going to give me 2y. I'm going to add 5, that's going to give me 8. What does y need to be? Y needs to be 4. Alright, so let's move on. Let's go to the next part, the next chapter, and write some more stuff down. Alright, so we got 6.6 now. Let's go through this really quickly. We're going to be talking about trapezoids. So make sure, and again, I pause the video, but I quickly write this all down. That's going to be very helpful, and definitely make sure that you have these two pictures. So all that, pause, write it down really quick, because this is going to be really important information. But a trapezoid is a quadrilateral. Quadrilateral, so 4 sides, with exactly one pair of parallel sides. So you see in this picture that these, which are called the bases, that they are both parallel to each other. The two sides that aren't parallel, we call those the legs. And the two angles, we call these angles the base angles. Okay? And so that is a regular trapezoid. There's also a special type of trapezoid which is called an isosceles trapezoid. An isosceles trapezoid, again, we have two bases are parallel. It's still a trapezoid, but what's special about it is that the two legs are congruent. Okay, so that's important. Isosceles trapezoid. Sure you have those pictures, that definition, but we're going. We're keep on going. Okay, so there's some properties that we need to know, and again, most of them are going to apply to the isosceles trapezoid. So the first one is, if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So again, we know that T and P are going to be the same, and R and A are going to be the same. Again, remember, that only applies to the isosceles trapezoid. The other thing, again, pause it, write it down, go on the next one. The other thing, again, this applies with an isosceles trapezoid. If it's an isosceles trapezoid, then the diagonals, which would be AC and BD, then they are congruent. Okay, another important fact. Pause it, write it down. Here we go. And the last one is this. It's what's called the trapezoid mid-segment theorem. Remember, we talked about mid-segment before. Middle. This point is in the middle. N is in the middle. Segment. Two of these connected together. That is a mid-segment. It's a line in the middle. And what's important about this is the mid-segment is parallel to the bases. Alright, so obviously, these are all going to be parallel. They're all parallel to each other. And they look kind of parallel, right? And then the other one is the length of the mid-segment is half the sum of the two lengths of the bases. So that's this, number 2. So make sure you pause it, write all that down. And you don't need to write this down, but this is just kind of an overview of what we're talking about. Okay, we have in this whole section so far been talking about quadrilaterals. We spent some time talking about parallelograms. And remember, in the parallelogram family, we got rectangles and we got rhombus. And remember, basically, if you put all the attributes of a rectangle rhombus together, you make a square. Okay, but again, not all quadrilaterals are parallelograms. You also have a trapezoid. Trapezoids have one pair of parallel sides. Parallelograms have 2. So you got a trapezoid, and with the trapezoid, again, there are special ones, which is called an isosceles trapezoid, where these two sides are the same. We're not talking about kites today, so again, just kind of an overview of what we're doing. Let's do a few problems and call it a day. Alright, first problem, make sure you write it down. And we have an isosceles trapezoid. So remember, an isosceles trapezoid, there are some special things that we need to know, and one of them is that the base angles are the same. So that means that F is 65 degrees. The other thing, how can we find out D and how can we find out E? Well, remember, a trapezoid the bases are parallel. So I'm like, all right, these are parallel. When you have this, remember, these angles, D and C, they're same side interior angles. Same side interior angles are supplementary, which just means that they add up to equal 180 degrees. So 65 plus 115 is 180 degrees. And remember, so that's 115. Remember that D and E, base angles are the same, so that's got to be 115 as well. Okay, again, special properties with an isosceles trapezoid. Cool? Next one. All right, here we go. Last problem. It says QR is the mid-segment. So what do we know about mid-segment? First, it's in the middle. And it's a segment, right? The other thing that we know is that all three of these lines are parallel. That will be important if we're talking about angles, but we're not talking about angles, we're talking about the lengths of the line. So how can we find the mid-segment? Well, remember that formula that you wrote down, the mid-segment. So QR, the middle, is going to equal, if you take the top, which is LM plus, and the bottom, PN, if you take those together and divide it by 2, then you get the mid-segment. So all that is, and you wrote that theorem down before, is the top one right here. We're going to take the top one, we're going to add it with the bottom one, we're going to cut it in half, divide it by 2, and we're going to get length of the middle one. So all we need to do is just, let's plug in these numbers. Well, what's QR? QR is x plus 2. What's LM? Well, that's 4x minus 10. What's PN? Well, we're going to combine together, which means add. We're going to add it with that one. And what are we doing with that? We're going to divide it by 2. Alright, so let's get x all by itself. I'm going to times 2 to both sides. So we're going to get 2x plus 4 equals 4x minus 2. I'm going to subtract 2 over so I can get this 2x. I'm going to add 2 over, so I'm going to get 6. So what is x going to equal? X is going to equal 3. Okay, again, remember, for the mid-segment, it's just the top and the bottom added together, divided by 2, and you get the mid-segment. Cool? Thanks for watching. I'll see you guys all soon.